With increasing focus on exploring Mars, we're showered with amazing data in the highest resolution of the Red Planet. More probes, orbiters, rovers, and science demonstrators are at Mars right now than ever before. However, it's good to remember a time when there weren't even low-resolution images, let alone data of any kind. A time before Hubble, MRO, or even the Viking landers. A time when Earth-based telescopes still could not produce fuzzy images of our closest neighbors in the visual spectrum. In the 1960s, Project Mariner was the main focus of interplanetary research. Fielding the first probes to have 3-axis non-spin stabilization, they would also use stars for navigation. Its solar panels angled towards the sun at all times, while the probe used attitude control jets to keep its orientation. Using the soon-to-be-available Atlas launch vehicle, the Mariner program was funded in 1960 with a series of JPL mission studies for small probes sent to the inner planets. The Mariner program would also begin developing the Deep Space Network as a collection of ground stations around the world for communication with probes. All Mariner spacecraft were designed on a hexagonal or octagonal bus. This was the main body of the probe, containing all of its electronics, and where all components were attached, including antennae, cameras, propulsion, and power sources. Beginning with Mariner 3, all probes had 4 solar panels for power, with the exception of Mariner 10, which had 2. All of the probes would also carry TV cameras. Part of the Mars 1964 campaign, NASA's Mariner 3 was designed to take pictures of Mars after an 8-month trip. It launched on November 5, 1964 and reached low Earth orbit. The probe, however, lost power 8 hours after launch, and its solar panels never unfurled, failing its goal of a Martian encounter trajectory. Due to a faulty payload shroud that did not detach, the mass of the spacecraft was incorrect when attempting to burn towards Mars, and thus never entered a proper trans-Mars trajectory. The probe ended up in an unanticipated heliocentric orbit. Using a new metal shroud on Mariner 4's Atlas launch vehicle, NASA was hoping they had solved their previous issue.
Spacecraft to internal power. Head to the start.
On November 28, 1964, the spacecraft lifted off without any issue and was successfully boosted towards Mars by the Agena upper stage. Making a single course correction on December 5, 1964, NASA ensured that the spacecraft would fly close to the Martian surface. With some of the instruments on Mariner 4 failing to make intelligible reads during the trip to Mars, engineers were hard at work keeping track of all systems. Following the 228-day journey, it was time to wait for the first data to be sent back from the probe. On July 14, 1965, Encounter Day gripped everyone at JPL and NASA, with the probe about to pass by Mars' surface at just 6,000 miles or 9,800 kilometers. The single pass by Mars meant they had to get as much data back as possible from the probe. With trajectory readouts where they were expected to be, Mariner 4 began to send back images, sensor data, and signal data. For 8 hours after its flyby, the data is downlinked to NASA computers and reviewed by engineers. The first picture of Mars was transferred in 240,000 bits of binary code to make a shaded 40 kilopixel image. This image, small and with poor resolution for 2023 standards, was the first image any human had seen of a planet other than Earth. Through October 1st, engineers continued to look at the data beamed back and even attempted color shading some of the images. The scientific data was showing that Mars was an immensely cold and cratered planet with a wispy thin atmosphere. The first images showing craters led scientists to dismiss the possibility of life on the surface. It confirmed the sensor's thin registered atmosphere, but enticed researchers to explore more. They wanted to know how long the planet had been without an atmosphere, as the craters implied it had been a very long time. The cold and barren planet that Mariner 4 had flown by had no signs of canals or surface activity as previously discussed by astronomers. The thin atmosphere was seen to be almost entirely made up of carbon dioxide, without any oxygen at all. In total, the 22 pictures would cover only 1% of the Martian surface. Many geological features like valleys, mountains, canyons, and basins were not imaged by Mariner 4, but would be targets of subsequent missions. Mosaics and further studies of the original 22 pictures jump-started scientists' ideas on what to photograph next. With the scientific and historical achievement as wind at their backs, NASA and JPL began planning for Mariner 6 and 7, which would further our understanding of Mars. Launching both Mariner 6 and 7 in early 1969, The probes would reach Mars by late July. All of the instruments aboard the two probes would focus solely on Mars, covering its surface, atmosphere, and composition. Mariner 6 took 24 near-encounter photos during a period of 17 minutes, which were stored on a tape recorder and later transmitted back to Earth. Following communication issues with the high-gain antenna on Mariner 7, the probe was able to send back 126 photos of Mars, the most to date. In some, the very first evidence of the Martian moon Phobos was found. The science from Mariner 7 confirmed that Mars was extremely cold, but for the first time denoted terrain that was higher than its surroundings. Mariner 8 and 9 would make up part of the Mars 1971 campaign and would attempt a new goal, achieving Martian orbit. A failure on ascent for Mariner 8 in May of 1971 relegated its twin as the sole probe for the mission when it launched on May 30th, 1971. All scientific instruments on Mariner 9 were mounted on a movable scan platform underneath the main body. The spacecraft spanned about 22 feet, including its solar panels. The primary goal of the mission would be to map 70% of the surface in 3 months of operation. On November 14, 1971, Mariner 9 used its main engine for over 15 minutes to become the first human-made object to enter orbit around another planet. The initial orbit was highly elliptical, at a 64-degree inclination. The incoming data disproved the idea that Mars was void of geological features. Speculation about the possibility of water having existed remained, however, as the probe could not provide any conclusive proof. By February 1972, the spacecraft had identified about 20 volcanoes, one of which would later be named Olympus Mons. Thanks for watching. If you enjoyed content like this, please consider subscribing, liking, sharing, and commenting on this and other future videos. Also, remember to follow us on Twitter and Instagram for more space content.